Walk outside on a clear night and it is very easy to feel like the sky is a map of places, a bright point there, a dim point there, a haze across the dark, all of it arranged above us like remote geography. But James Webb has pushed that old feeling into something much stranger, because some of what it is now measuring is not simply far away. It comes from a time when the universe itself was barely out of its beginning, when galaxies should still have been small, dim, and unfinished. And yet Webb is finding places where stars were already forming at record distances, so early that the old timeline for how quickly light and structure emerged no longer feels as comfortable as it did. If you enjoy long journeys like this, settle in with me and stay to the end. This is one of those discoveries that starts as a headline and slowly becomes a different way of seeing the night. So let's begin with something familiar. Most of us grow up with a simple idea about the sky. The moon is close, the sun is farther, the stars are very far, galaxies are farther still. That is all true, as far as it goes. But it leaves out the part that really changes your perception, which is that distance in astronomy is not just distance. It is delay. It is history. It is a record of what things were like when the light began moving. That sounds abstract until you let it settle into the body. Imagine getting a letter that took so long to arrive that the country it came from no longer existed in the same form. Imagine hearing a voice message from someone recorded before your grandparents were born. In ordinary life, delays like that are impossible. In astronomy, they are normal. When we look at the sun, we see it as it was about 8 minutes ago. When we look at the Andromeda galaxy, we see it more than 2 million years in the past. By the time Webb reaches into the deepest dark, the delay is no longer human, historical, or even planetary. It becomes primordial. That is the real threshold here. Webb is not just seeing remote galaxies, it is catching them when the universe was less than 300 million years old, roughly 2% of its current age. If the cosmos were a person living to old age, this light would come from a moment so early that the child was barely more than a newborn. And yet the picture we're getting is not of a silent crib. It is already busy, already bright, already working. This is where the title stops being a technical claim and starts becoming something you can actually feel. Star formation at record distances means the early universe was not waiting around in some dim, shapeless pause. Matter had already gathered, gas had already collapsed, gravity had already found places dense enough to kindle light. In some of those places, the process was energetic enough that Webb can do more than notice a faint smudge. It can begin to read what is happening inside. That changes everything, because there is a big difference between detecting a remote object and measuring its condition. One is like noticing a street lamp through heavy rain. The other is like being able to tell what kind of bulb it uses, how much power it draws, and how the air around it is being heated. At the frontier Webb is working on, that distinction matters more than almost anything else. The deep result is not simply that very distant galaxies exist. Most astronomers expected some galaxies to exist there. The deeper shock is that some of them are luminous enough, compact enough, and active enough to let us inspect the pace of cosmic growth much earlier than many people were prepared for. The record-setting galaxy at the center of this story carries a plain, almost bureaucratic name, JADES-GS-Z14-0. A label like that does not sound like revelation, it sounds like inventory. But hidden inside that dry catalogue name is one of the most extraordinary measurements ever made. Its light comes from a time less than 300 million years after the Big Bang. That number alone is severe, not because it is large, but because it is small. There had been so little time, and time is the whole tension. When people hear 300 million years, it can still sound enormous, because any number in the millions escapes daily intuition. But cosmic history has a way of changing the scale under your feet. Our species has existed for only a tiny fraction of that span. Recorded human history occupies only a sliver of it. All empires, all cities, all songs, all wars, all languages written in books, all of it would fit into a very thin surface layer compared with the interval between the Big Bang and the light from this galaxy beginning its journey. Yet from the universe's point of view, 300 million years is almost alarmingly early. It is not late enough for patience. It is barely enough time for the first large chapters to start being written. So the old picture many people carry in their heads is understandable. Early means simple, early means dim, early means primitive. If you look far enough back, you expect reality to become sparse and hesitant, like arriving at a construction site before dawn and finding only some marked ground, a few trenches, and piles of raw material waiting for work to begin. What Webb is showing us is more unsettling than that. It is as if we arrived before sunrise and found steel already standing. To understand why, we need to hold two truths together at once. The early universe really was different. It was hotter in its history, denser overall, and filled for a long period with neutral hydrogen gas that absorbed and scattered the energetic light from the first sources. This was not an easy environment for observers billions of years later. It was more like trying to see campfires through a vast cold fog. The darkness was not empty. It had texture. It had resistance. That is one reason these detections feel so powerful. The farther back we look, the more the universe becomes a difficult medium, not just a larger one. Light has to survive the journey. Signals arrive stretched. Details blur toward invisibility, and still Webb keeps finding them. You can think of a redshift as the universe changing the color and pitch of a signal during its travel. We are used to the sound of a siren dropping lower as it moves away from us. With cosmic redshift, the effect is not caused by a car moving through air. It is caused by space itself expanding while the light is in transit. Wavelengths get pulled longer and longer, as if a note were being drawn out on an instrument until it sinks below the register where your ears expected it. Light that began in the fierce ultraviolet glare of newborn stars arrives stretched into the infrared, where Webb was built to listen. That is why this telescope matters in such a specific way. It is not just stronger vision, it is vision tuned to the ancient, reddened after traces of first light. It was designed for exactly this kind of work, to catch radiation that left young galaxies billions of years ago and has been stretched into a quieter band by the growth of the universe itself. And once that light is gathered, the real reading begins. Because a distant galaxy is not just a dot. Buried in its light are clues about how intensely stars are forming, how much gas is being excited, how compact the system is, and even whether earlier generations of stars have already lived and died inside it. That last point matters more than it may sound right now, because it means Webb's record distances are not only telling us where light existed, they are beginning to tell us how quickly the universe learned to build complexity from darkness, which is a much more demanding question than simple distance ever was. If a galaxy that remote were only barely shining, the story would still be impressive. It would confirm that structure had emerged. But some of these systems are not behaving like apologetic first drafts. They are small, yes, but they are doing real work. They are compact engines. Their light suggests intense activity packed into tight regions, as though the young universe had found ways to be unexpectedly efficient in certain pockets, almost as soon as the first opportunities for structure appeared. That is where the emotional force of this discovery begins to sharpen. We are not just watching the clock rewind. We are discovering that when the clock was near the beginning, some parts of reality were already moving fast. Fast enough that the old, comfortable image of a long, dim waiting period starts to fray. That does not mean everything astronomers thought before Webb was wrong. It means the margin for slowness has narrowed. The room for leisurely assembly has shrunk. A distant galaxy like JADES-GS-Z 14-0 does not demand a dramatic overthrow of cosmology. What it does demand is seriousness about how quickly ordinary matter, under gravity, could collect, cool, ignite stars, and begin changing itself. The pressure falls not on the existence of an expanding universe, but on the timeline of how efficiently some of its first luminous systems got to work. There is something almost unnerving about that phrase, got to work, because it makes the early cosmos sound industrial. In a sense it was, not with machines, not with design, but with process. Gravity pulled gas into denser knots. Those knots lost heat. As they cooled, collapse accelerated. Pressure rose. The first generations of stars ignited, and the darkness was no longer simply darkness. It became a place where energy was being poured into surrounding gas, where radiation was reshaping local conditions, where the plain ingredients left from the beginning were entering new states. This is the heart of star formation, and it is worth slowing down here, because it is easy for the phrase to pass by like background music. Star formation is not a decorative detail. It is the mechanism by which the universe stops being chemically simple. It is the reason there are furnaces hot enough to forge heavier elements. It is the source of ultraviolet light intense enough to ionize surrounding gas. It is the beginning of feedback, of enrichment, of change rippling outward from compact bright regions into the wider medium around them. When Webb measures signs of star formation at record distances, it is measuring the earliest known places where that transformation is already underway. And that word underway is doing a lot of work, because we are not talking about a switch flipping once and then the story being complete. We are talking about an ongoing process inside remote galaxies, one that leaves fingerprints in the light. Young hot stars pour out radiation that excites nearby gas. That gas then emits at particular wavelengths. If those wavelengths are stretched by cosmic expansion into the infrared or even farther, and your telescope is sensitive enough, you can begin to infer what kind of environment produced them. The light becomes less like a postcard and more like an echo from inside a room you cannot enter. This is one of the most beautiful things science does, though beautiful is almost too soft a word for it. It is an act of disciplined listening. We do not cross the distance. We do not touch the source. We take the signal that arrives, faint and delayed, and ask what kind of place could have made it. In ordinary life, this would be like hearing music through a wall and figuring out not only that there is an orchestra inside, but roughly how large the room is, how many instruments are playing, and whether the air is thick with heat. At these redshifts, even that analogy understates the challenge. The wall is not next door. The wall is most of cosmic history. That is why it matters that Webb is not working alone in spirit. Even when one observatory gets the headline, different instruments and facilities contribute different kinds of reading. Webb excels at detecting and characterizing very distant galaxies in infrared light. Other observatories can then tighten measurements, or detect specific features that sharpen the story. So the discovery is not just one miraculous glance. It is a layered act of verification and interpretation. A signal is found. Its redshift is pinned down. Its brightness is examined. Its emission features are considered. Its physical state becomes less imaginary. And as that physical state comes into focus, the same question keeps growing larger. How could so much already be happening? Part of the answer is that the universe was not uniform in the way our casual language sometimes makes it sound. When people say the early universe, it is easy to picture one smooth condition everywhere, as though all of space were advancing at the same pace. In reality, even small initial differences could grow under gravity. Some regions became denser sooner. Some halos of dark matter gathered ordinary gas more effectively. Some environments were better at turning that gas into stars. So the frontier we are observing is not a perfectly even shoreline. It is patchy, uneven. In some places, progress outran the average. This is important because otherwise a single record galaxy can feel too singular, too much like a cosmic loophole. But Webb's deeper field suggests something broader, not an absurdly crowded universe at the dawn, not a sky full of mature giant spirals appearing impossibly early, but a genuine population of compact, distant galaxies that do not vanish as quickly as a simpler intuition might expect. They become rarer. They become harder to detect. Yet they are there, and some of them are active enough to force a more demanding conversation. You can picture it like fresh snow at first light. From far away, the surface looks smooth and blank. Then as your eyes adjust, you begin to notice tracks. Not everywhere, not densely, but enough to tell you that motion started earlier than you thought. The snow is still mostly undisturbed, and the morning is still young, but the evidence of activity is no longer optional. That is what these measurements are doing to cosmic dawn. There is another subtle shift hidden in all this, and it matters for how we should feel the discovery. For a long time, the extreme edge of the observable universe was a place of philosophical language, the first light, the first galaxies, the beginning of structure. Those phrases were real, but they floated slightly above measurement for most people. They lived in diagrams, in artist impressions, in broad timelines told with a kind of respectful vagueness. Webb is changing the texture of that vagueness. Now the frontier has object names, redshifts, estimated sizes, star formation indicators. This does not make the beginning ordinary, it makes it more intimate, stranger, in a way. A place that used to feel like pure abstraction now has individual entries. each one a remote little system whose light can be separated, studied, and compared. The opening act of cosmic structure is becoming less mythic and more legible. And legibility can be more emotionally powerful than mystery alone. Mystery without contact keeps reality far away. Measurement draws it closer without making it small. That is the balance Webb keeps striking. It does not shrink the early universe into something tame. It simply gives us handles, enough to start lifting. The most immediate handle is brightness. JADES-GS-Z 14-0, and other extreme systems matter partly because they are luminous enough to be seen and studied despite the distance. Brightness in astronomy is tricky, because what we observe depends on both intrinsic luminosity and the effects of distance, expansion, and sensitivity. But the intuitive version is simple. If something this remote still stands out in the data, it is telling you that real processes inside it are already producing significant amounts of light. And light at these wavelengths is not just decoration. It is evidence of energy budgets, stellar populations, gas conditions, and growth. A very distant luminous galaxy is a report that nature was already able to gather matter into a compact region and make that region shine with enough force to survive an almost incomprehensible journey. That is not a trivial report. It is a statement about efficiency. A small system doing outsized work is often more revealing than a large system behaving normally. In human terms, it is the difference between a sprawling city with expected output and a tiny workshop somehow producing far more than its size suggests. The workshop makes you curious about the conditions, the methods, the pace, the source of its intensity. These early galaxies create a similar curiosity. They are compact, but not passive, dense, but not dormant. Which brings us to a deeper discomfort in the old mental picture. We often imagine the beginning of things as clumsy, a child learning to stand, a civilization building its first huts, a machine starting with the rough prototypes. But some beginnings are violent accelerations. Some systems, once conditions cross a threshold, move faster than our intuition allows. Water held behind a dam can seem patient right until the moment it is not. A forest can look still until a fire finds a line of dry fuel. In the young universe, gravity and gas were capable of that kind of threshold behavior. Once dense structures began to form, some places did not proceed cautiously. They surged. That is why this record-distant star formation has such a pull. It reveals not just an early scene, but an early tempo. And the tempo is the thing we were not fully ready for. Ready for, perhaps, because human intuition is trained on lives, not on primordial structure. We know what it means for a child to grow slowly, for a building to take months, for a forest to take years. We do not naturally know what it means for matter spread across immense volumes to discover, under gravity, a route to concentrated brightness in such a short cosmic interval. Our instincts keep trying to import calm timelines into a reality that was under no obligation to honor them. So let the scale become physical for a moment. The light from one of these record galaxies began traveling toward us when the universe was still in an age that many models treat as a frontier of assembly. Earth did not exist in anything like its present form. The sun had not yet formed. The oxygen in your blood was not waiting somewhere in a quiet reserve. It had not been made. Almost everything familiar to the body belongs to a much later chapter. And yet, while all of that future absence still held, some compact galaxy had already become luminous enough for us to detect, and active enough for us to start asking what kind of stars were burning inside it. That is an astonishing reversal of emotional perspective. We often think of ourselves as latecomers looking back on remote simplicity, but the measurements coming in from Webb suggest that reality was capable of becoming locally busy and complicated very early. Not everywhere at once, not in finished grandeur, but in islands of rapid construction, in pockets where the universe was already taking plain hydrogen and helium and turning them into starlight. You can imagine dawn over a town that should still be dark. The horizon is only beginning to pale, yet some windows are already glowing, some ovens are already hot, some workshops are already making noise. The world as a whole is still mostly night, but there are districts where activity has begun ahead of the average. That is much closer to the emotional truth of these observations than the old picture of a uniformly sleepy beginning. And this is where another misconception needs to be taken apart carefully. When people hear early galaxy, They often imagine something like a miniature modern galaxy, just smaller and blurrier. That is not quite right. These distant systems are not tiny versions of familiar mature spirals with serene disks and well-settled structures. They are compact, intense, and in many cases probably turbulent places, where gas is moving, stars are forming rapidly, and radiation is transforming the surrounding medium. They are closer to concentrated sites of assembly than to finished cosmic architecture. That matters because it keeps us from reaching for the wrong visual comfort. Webb is not peering back and finding fully grown cities where there should have been villages. The surprise is subtler and, in some ways, more interesting. It is finding that even while the larger cosmic environment was still young and difficult, some places were already efficient at lighting up, gathering matter, and imprinting themselves into the record. Efficiency is a quiet word for a dramatic fact. The more closely astronomers inspect these galaxies, the more they look like systems that are doing a lot with relatively little. Their sizes can be remarkably small compared with later galaxies, yet their luminosity and inferred activity tell us that a great deal is happening inside those compact regions. This is one of the reasons the discovery has such tension. If a source is distant and active but physically small, then what we are seeing is not leisurely sprawl. It is concentrated labour. You could compare it to seeing a tiny forge from miles away at night. The building itself might be small, but the heat pouring out of it tells you something intense is happening inside. That is what many of these remote galaxies feel like in the data. Compact furnaces, early concentrations of matter where starlight is already being produced vigorously enough to cross almost the entire observable history of the universe. And once you start thinking in those terms, the next question becomes unavoidable. If stars were already forming this early, what was that doing to the universe around them? This is where the story widens beyond individual objects and becomes a story about environment. The young cosmos was filled with hydrogen gas that, for a long stretch, remained neutral. That neutral gas was very good at absorbing certain kinds of energetic light. So when the first generations of stars and galaxies began to shine, they were not just adding points of brightness to darkness, they were changing the state of the surrounding medium. Their radiation ionized nearby gas, carving out bubbles of altered space around themselves. Over time, enough of these sources formed, and enough bubbles grew and overlapped, that the universe underwent a large-scale transition. Darkness did not merely get interrupted, it got reworked. This transition is often called reionization, but the name alone can feel clinical, as if it belonged in a textbook diagram. The lived meaning is more vivid. Imagine an immense foggy plain before sunrise, where scattered fires begin to appear. At first, each fire only clears a little space around itself. The fog remains dominant, but as more fires ignite and the cleared circles expand, the plain slowly changes character. Visibility grows in patches. The medium itself becomes different. The night is no longer one thing. That is the larger importance of measuring star formation at record distances. We are not just counting early lights. We are tracing the agents of that transformation. And because of that, even a compact galaxy at redshift 14 is not merely a curiosity at the edge of the map. It is part of the mechanism by which the universe became more transparent, more structured, and more readable to everything that followed. Those remote bursts of star formation helped create the conditions for later cosmic history. In a very real sense, when Webb studies them, it is looking at some of the earliest labour that made the later universe possible. There is a certain calm shock in that thought. The night sky we see above us now looks finished, or at least settled into an old order. But there was a time when light itself was still negotiating for territory. The title begins to deepen here. James Webb just measured star formation at record distances. That can sound, on the surface, like a record book achievement, another entry in the sequence of farthest this and earliest that. But a record is not the true prize. The true prize is that the measurement connects distance to process, not just where something is, not just when its light left, but what it was doing. It tells us that star formation was already underway so early that the larger chronology of cosmic dawn has become more sharply drawn. That is why the record keeps paying off the farther you follow it. At first the reaction is simple awe at the distance, then distance turns into time, then time turns into pace, then pace turns into physical consequence. By the time you arrive there, the discovery no longer feels like an isolated marvel. It feels like evidence that the beginning was not quiet for long. Still, we have to keep our footing. There is always a temptation, especially with frontier discoveries, to leap from "this is surprising" to "everything we knew was wrong." That is almost never the most intelligent response, and it is not the strongest one here. Science usually moves by pressure, not by theatrical collapse. A measurement arrives, a model strains, parameters shift, assumptions are tightened. Processes that seemed adequate begin to look too slow in some regimes. The structure remains, but the demands on it increase. That is a more honest kind of drama, and I think a more satisfying one. Reality does not need us to exaggerate it. A compact, active galaxy shining at such an early epoch is already enough. It already tells us that some pathways to star formation and growth were faster, or more efficient, or both, than a simpler picture allowed. That is not a failure of understanding. It is understanding getting more specific. And specificity is where the next surprise begins to gather. Because once you can do more than detect these galaxies, once you can begin to read the signals tied to their internal conditions, a deeper question opens. It is one thing to say stars are already forming. It is another to ask whether previous stars in such a galaxy had already lived, died, and begun changing its chemistry. That is where the story starts to move from light into memory. Because chemistry is memory. A newly born universe begins with a very short ingredient list, mostly hydrogen, a great deal of helium, traces of lithium, not much else. That simplicity matters. It means the first stars were not forming in a cosmos already enriched by long histories of stellar life. They were working with raw material close to the opening composition of the universe itself. So when astronomers find signs of oxygen in an extremely distant galaxy, the significance is not sentimental, and it is not about biology. It is about sequence. Oxygen means previous generations of stars had already burned, lived out their brief bright lives, and returned processed material back into space. That is a profound change in what the frontier can tell us. Until you think about it carefully. Oxygen detected in a faraway galaxy may sound like just another ingredient on a list, but in an object this distant, oxygen becomes a clock with teeth. It tells you that star formation there was not merely beginning in the moment we see. Enough time had already passed for some stars to form, evolve, and enrich their surroundings. The galaxy was not only lighting up, it was already remembering earlier light. This is where the quiet shock deepens. We start with a record distance, and the mind is impressed by remoteness. Then we learn that the remote source is actively forming stars, and the mind adjusts to early activity. Then comes the chemical clue, and suddenly we're no longer dealing with a first flicker alone. We're dealing with at least a partial second act. Something in that compact galaxy had already gone through a stellar life cycle, fast enough to leave oxygen behind. The universe, in that place, had already moved beyond simple ignition into processing. That is not the same as maturity. It would be misleading to imagine a settled galaxy full of old generations quietly orbiting one another. This is still a very early system, small, intense, probably unstable in the ways young things often are. But it is no longer chemically innocent. That is the crucial point. The first darkness had already been interrupted long enough, and productively enough, to alter the composition of the gas. If you walked into a room and smelled smoke, you would not need to see every flame to know burning had happened. Oxygen in one of these record-setting galaxies functions in a similar way. It is not the whole fire. It is evidence that the fire has already been going. And that brings us closer to the real force of measurement. Webb and other observatories are not just handing us more impressive distances, they're giving us stages of implication. Existence implies structure. Brightness implies energy. Emission features imply active star formation. Oxygen implies prior stellar generations. Each layer makes the earlier layer feel larger in retrospect. The discovery keeps unfolding after the headline. That is one reason the tone around Webb can sound almost disoriented at times. Not because astronomers are confused in the simple sense, but because when new data lands at the edge of expectation, language has to catch up. Old summary phrases become too soft. Early galaxy begins to feel inadequate. Distant source feels bloodless. Even cosmic dawn can sound too smooth for what is actually being revealed. Because dawn suggests a gentle brightening, when the reality appears to have included compact zones of rapid activity, quick enrichment, and strong radiation long before many casual listeners would guess. It helps to imagine the frontier not as a blank page slowly receiving its first mark, but as paper where the ink has already begun to spread in a few places before you expected the pen to touch down. Not complete coverage, not uniform darkness shattered all at once, but enough early marks to tell you the process began with more urgency than your intuition supplied. And still, the most interesting part is not that the early universe was somehow ahead of schedule, as though it had violated a timetable. Nature does not have a calendar pinned to a wall. The interesting part is that our mental timelines were coarse. We knew stars and galaxies had to emerge. We knew ionization had to happen. We knew matter under gravity had to build structure. But the exact tempo, especially in the first few 100 million years, remained something models had to infer with limited direct evidence. Now the evidence is improving. The room is not brightly lit yet, but it is no longer dark enough for easy assumptions. That improvement in evidence comes from the way light carries fingerprints. A galaxy's glow is not one smooth anonymous wash. Buried inside are features produced by atoms and ions interacting in specific conditions. These features can tell astronomers about hot young stars, energized gas, and the pace of formation. Some of the most important clues do not sit in the same part of the spectrum where the light began. Cosmic expansion stretches them into longer wavelengths, which is why infrared and beyond become essential. Webb was built to catch this shifted record, and when it does, we're no longer staring at a blur and guessing wildly. We are reading traces. Reading traces is a different emotional experience than merely admiring distance. It feels closer to forensic work, but on a scale so extreme that the word hardly seems adequate. This is not a detective kneeling in a room with a flashlight. It is a species on one rocky planet building instruments so sensitive that they can infer physical conditions in galaxies whose light started toward us before our own star was born. The technical achievement is real, but the larger feeling is stranger than pride. It is a kind of earned access. We do not belong naturally at this edge of knowledge. We built our way there. That is worth pausing on because the deeper this script goes into remote epochs, the easier it is for human beings to disappear from the frame. Distances swell, ages widen, galaxies take over the imagination. Yet the whole meaning of the story changes if we remember who is measuring it. We are not spectators floating outside the universe with a perfect view. We are creatures who evolved under a local sky, learned optics, mathematics, and engineering, and then extended our perception outward until even the first major structures in cosmic history began to leave readable marks in our data. The measurement is cosmic. The act of measuring is intimate. And intimacy changes how the frontier feels. A purely abstract universe can be impressive without being moving. But once you remember that the oxygen in one of these remote galaxies is being inferred by minds that breathe oxygen forged in later generations of stars, the story acquires a quieter symmetry, not mystical, just real. The same broad stellar processes that eventually made the chemistry of worlds like ours are being detected in a much earlier chapter, when those processes had only recently begun to carve themselves into matter. This is why star formation at record distances is not a narrow specialist phrase. It is a sentence about continuity. It connects the beginning of cosmic light production to the long later chain that leads to heavier elements, planets, atmospheres, and eventually organisms able to wonder where all of it came from. The discovery is not about us in any central sense, but it does include us in the story of what stars set in motion. Still, caution matters here. Oxygen in such a distant galaxy does not mean the universe was already rich in heavy elements everywhere. It does not mean the dawn was effectively over. It does not mean one unusual object stands in for the whole epoch. Frontier astronomy is full of selection effects. The objects we detect most clearly can be the exceptional ones. Deep fields may favor the sources most likely to stand out. A luminous compact galaxy at extreme redshift is informative, but it may not be typical. That uncertainty is not a weakness in the story. It is part of its truth. In fact, it makes the story stronger, because it forces us to distinguish between what is securely known and what is being inferred. The distance can be pinned down with impressive confidence. The presence of certain lines can be studied. The case for active star formation can be made from the light. The broader interpretation that some pathways to early growth and enrichment were surprisingly efficient is strong. But beyond that, care is wise. This is not the end of the conversation. It is a sharper beginning, and sharper beginnings can be more disruptive than endings. Because now we have to ask not just how one galaxy became so informative so early, but what kind of broader population sits behind it. Was this object a lucky outlier, a bright flare in a largely dim era, or is it one of the more visible members of a real underlying frontier population, a sign that the early universe contained more active star-forming systems than our softer intuitions preferred? That question leads us from the single striking source back into the deep fields themselves, where Webb has been doing something almost patient in its power, staring into tiny dark patches of sky until a population begins to emerge. A deep field is one of astronomy's most beautiful acts of stubbornness. You point a telescope at a patch of sky that looks almost empty to the eye, and instead of glancing away, you stay. You keep collecting light, minute after minute, hour after hour. In ordinary life, staring harder at darkness does not usually reward you. In this case, it does. The black fills with structure. The apparent emptiness begins to disclose a hidden crowd. That crowd is not random background decoration. It is a cross-section of time, nearby objects, more distant ones, fainter, earlier sources. The deeper the exposure, the farther down the timeline the instrument can reach. And when Webb performed this kind of patient excavation with its deeper surveys, something started to happen that made the frontier feel less like a single lucky detection and more like a changing census. Extremely distant candidates began to appear in numbers large enough to matter. Not countless numbers, not a sky overflowing with impossible galaxies. The early universe still becomes sparser as we push back toward its first few 100 million years. Sources become rarer. The luminosity density drops. There is no sense in which Webb has found a fully crowded mature cosmos sitting immediately after the beginning. That would be a caricature. But what it has found is more interesting than caricature. The decline is real, yet the population does not vanish into near nothingness as fast as many people would instinctively imagine. The frontier contains enough galaxies to be measured, compared, and argued over. And the moment you have a population instead of a solitary marvel, your understanding changes. One object can always feel like an exception, a brilliant fluke, a strange survivor at the edge of possibility. A population, even a small and difficult one, forces you to think statistically. It asks about trends, about brightness distributions, about sizes, about number density, about whether these compact star-forming systems were rare accidents, or whether the young universe regularly built luminous pockets quickly enough for us to notice. That shift from anecdote to pattern is where astronomy becomes more demanding and, in a deeper sense, more rewarding. Because patterns are harder to dismiss. If you find one set of footprints in fresh snow, you can imagine an unusual passerby. If you begin to find many, spaced across the field, then the morning itself takes on a different meaning. Movement was part of the scene. Activity was not singular. The same is true here. Webb's deepest observations suggest that as we move toward redshifts above 10, and then toward 12, 13, and beyond, we are not peering into a void that only occasionally coughs up one improbable source. We are beginning to see a landscape where early galaxies really are present, though challenging, scarce, and often compact. This matters because the title promise grows stronger with every such object. Measured star formation at record distances becomes more than an isolated triumph. It becomes a statement about the universe offering up an actual frontier population of star-forming systems. The individual record holder is still precious, still dramatic, still the center of gravity for the emotional story. But behind it, there is now a dim company. A set of other sources helping us understand what kind of era it belonged to. And what kind of era was that? Not a finished one, not an empty one either. It was a time of uneven ignition. That phrase is close to the core of this entire story, uneven ignition, because it captures the balance the data seems to be forcing on us. The cosmos as a whole had not completed the great transition out of its darker early state. Large regions were still dominated by neutral gas. Transparency was still being negotiated. Galaxies were still assembling. Yet within that broad unfinished condition, some places had already become intensely productive. Some halos gathered matter quickly. Some compact systems formed stars hard enough to announce themselves across nearly all of cosmic history. Some regions were already chemically marked by prior stellar life. Once you see that, the beginning stops looking like a smooth fade-in and starts looking more like islands of fire appearing across a cold ocean before sunrise. That image is not just decorative. It helps explain why the young universe can be both mostly untransformed and yet locally vigorous. We do not need everything to happen everywhere at once in order to explain the data. We need a patchy process in which a minority of regions became active early enough and intensely enough to leave strong signatures in the observations. Those islands of activity then contributed to the larger transition over time, helping ionize surrounding gas and alter the medium through which later light would travel. This patchiness is one reason the frontier remains so compelling. If the early universe were uniform, the story would be cleaner but duller. Measurement would reduce to average timing. Instead, cosmic dawn appears to have texture. Some places accelerated, some lagged. Some compact galaxies turned into bright beacons, while much of the wider universe remained far from settled. The earliest chapter was not a flat page, it had hotspots. And hotspots always raise a human question. What would it have looked like from inside one? Not to our eyes, exactly. Because the first stars and early galaxies emitted much of their energy in ways our bodies are not built to perceive directly. And because we are talking about environments no human could survive. But if you could stand, impossibly protected, in the vicinity of one of these systems, you would not be witnessing the calm dignity of a mature spiral galaxy turning through silence. You would be near a compact and probably turbulent region where gas clouds collapsed. Stars formed in dense clusters, radiation carved through nearby material, and the local environment changed rapidly relative to the immense background age of the cosmos. It would not feel ancient. It would feel urgent. That is another useful correction. We tend to associate great age with slowness, serenity, and distance from change. But the light Webb is measuring does not come from an old, settled universe. It comes from a universe in an early rush of structure building. The remoteness tricks the emotions. Something can be unimaginably far away and still represent a period of rapid local change. In fact, that is exactly what these sources are showing us. The effect on theory is subtle but real. Before Webb, models of galaxy formation already allowed for early structure. No serious picture had the universe idling in perfect darkness for ages and ages without anything happening. The question was pace, abundance, and efficiency. How many galaxies should appear at the highest redshifts we can reach? How bright should they be? How rapidly should they assemble stars? How quickly could heavier elements begin to show up? Webb is not answering these questions with a single clean sentence, but it is narrowing the space of acceptable answers. That narrowing is often where science becomes most alive, not when uncertainty disappears, but when it becomes harder to hide inside vagueness. And there was a lot of vagueness here before. Necessarily, we simply had fewer direct measurements this far back. The earliest galaxies lived mostly at the edge of detectability, which meant broad stories could survive because the frontier was poorly resolved. Now the frontier is sharpening, object by object, line by line, estimate by estimate. The early timeline is becoming less forgiving. Some ideas about gradual growth can still stand, but only if they are capable of producing compact luminous systems quickly enough. Some assumptions about chemical simplicity can still hold broadly, but only if they can make room for places that enriched earlier than expected. The canvas remains, but the brushstrokes are getting harder to fake. There is a calm kind of tension in that. Webb is not marching through the young universe with a trumpet, overturning everything in a blaze of headlines. It is doing something more consequential. It is forcing precision. And precision, once it arrives, can make an old picture suddenly feel thin. The deeper we go, the more we have to confront the fact that words like early and primitive do not mean what our intuition wants them to mean. Early can include compact brilliance. Primitive can include efficiency. A chemically sparse universe can still produce local complexity faster than an average description suggests. Those are not contradictions. They are warnings against letting broad labels become substitutes for understanding. So when we hear that Webb has measured star formation at record distances, we should hear more than a technical milestone. We should hear a revision of emotional scale. The beginning is not receding into greater abstraction as we approach it. It is becoming more textured, more specific, and in a certain way more crowded with consequences. That is the strange reward of deep fields. They do not just show us more objects, they teach us that reality was busier earlier than a casual human mind would ever have guessed. And once that lands, another question begins to rise from underneath it. If compact galaxies were already forming stars this early, and if at least some were already showing chemical fingerprints of previous stellar generations, how fast did the cycle inside those systems have to run? Fast enough that the phrase cosmic infancy starts to lose its softness. We use that phrase because it helps us feel how near the beginning this all was. Less than 300 million years after the Big Bang is, by cosmic standards, a very early chapter. But infancy in human life suggests fragility, hesitation, dependence, slowness. It suggests a creature not yet coordinated with itself. The galaxy's web is measuring force a more careful analogy. The universe was young, yes, yet in some pockets it was already capable of intense bursts of organization. The better picture is not a baby lying still. It is a newborn system finding, surprisingly quickly, where its muscles are. To see why that matters, it helps to think about what a stellar life cycle actually implies. A star is not just a light bulb turning on. It is a process that consumes fuel, generates pressure, balances gravity for a time, and eventually dies in ways that depend on its mass. The most massive stars live fast and end fast. They burn hot, hard, and briefly. In a quiet human frame of mind, a few million years already sounds like forever. In cosmic dawn, a few million years can be fast enough to matter enormously. That is one of the hidden engines behind the oxygen result. You do not need billions of years to begin enriching a small early galaxy if the first generations of stars include very massive ones. In that case, a compact region can move from collapse to ignition to feedback to partial chemical enrichment in a span that, though still vast to us, is short enough to fit inside the first few 100 million years of cosmic history. Suddenly the early universe is not just a place where stars might have begun. It becomes a place where stellar birth and stellar death had already started feeding into one another. This is where time becomes layered. At first we think in one clock. How old was the universe when the light left? Then a second clock appears. How long had that galaxy already been forming stars before the light we now see was emitted? Then a third arrives. How quickly did some of those stars live and die, returning oxygen and other products to the gas? The frontier is not a single timestamp. It is a set of overlapping timelines nested inside a remote source. Webb and its partner measurements are beginning to untangle those timelines from a signal that arrives stretched and faint after more than 13 billion years of travel. That is an astonishing thing to ask light to carry. Yet light does carry it, if you know how to read. The wavelengths where emission lines appear, the way the spectrum rises or dips, the brightness in particular bands, all of it forms a kind of coded report. Not a perfect report, not one free from ambiguity, but enough to move us beyond simple astonishment and toward reconstruction. A galaxy that remote becomes a place with inferred conditions, not just a distant fact. And once a galaxy becomes a place in the imagination, the whole discovery gets harder to flatten into a headline. You can begin to picture compact knots of star formation packed inside a tiny system. You can begin to imagine gas clouds collapsing under gravity, while the radiation from young stars pushes back, heating, ionizing, and stirring what lies nearby. You can imagine earlier short-lived stars having already seeded the gas with oxygen, so that the next round of star formation is happening in a chemically altered environment, not in completely pristine material. The place remains inaccessible. It remains almost impossibly far, but it stops being abstract. This is the point where a tired listener at night can suddenly feel the story move from scale into reality. Numbers alone do not do that. Numbers tell you where the frontier is. Process makes it inhabit the mind. There is a good reason astronomers care so much about this transition from pristine gas to enriched gas. Chemistry changes how matter cools. It changes the pathways available to clouds as they collapse. It changes the kinds of stars that may form and the way light interacts with surrounding material. In other words, enrichment is not just a badge proving that something happened earlier. It can influence what happens next. A galaxy that already contains some oxygen is not the same place it was before the first stellar generations lived and died inside it. It has been modified by its own history. That is why I said chemistry is memory. The gas remembers. Not consciously, of course, but physically. The material conditions in a galaxy are different after stars have processed and returned elements to the medium. A compact early system carrying oxygen is a system that has already been touched by its own past. It is no longer only beginning, it is beginning after something. That small phrase matters. Beginning after something. It gives the discovery a deeper emotional shape. The record galaxy is not a first note in a vacuum. It is part of a sequence already underway when its light set out toward us. We are not only seeing birth, we are seeing continuity, a place where one round of stellar life had likely already influenced the next. And as soon as continuity enters the story, the early universe feels less like a static museum exhibit and more like weather. Not weather in the earthly sense of clouds and rain, but a dynamic environment made of flows, thresholds, bursts, and feedback. One dense region lights up, radiation alters surrounding gas, massive stars die, elements spread. The next collapse begins under altered conditions. The same region, still tiny by later galactic standards, becomes a self-changing system. That picture is stronger and calmer than dramatic language about impossibility. The discovery does not need impossible, it needs sequence. That is more than enough. Still, there is something genuinely startling about how quickly the sequence seems to have begun in at least some systems. If the first few 100 million years of cosmic history already contain compact galaxies with signs of active star formation and chemical processing, then the opening era of galaxy assembly was not a gentle crawl. Certain places crossed important thresholds quickly. The first major structures did not all wait politely for a later epoch to become interesting. In a way, this should not surprise us too much. Gravity is patient in the large view, but ruthless once density builds. A cloud can drift for a long time in apparent calm, then collapse hard once conditions tip. A valley can seem quiet until runoff finds a channel, and then water gathers power rapidly. The young universe was full of raw material and growing differences in density. Once the right pockets deepened, the route to early star formation may have been swifter than a human mind, addicted to gradualism, would naturally imagine. That addiction to gradualism is worth naming because it shadows so much of how we picture cosmic history. We like smooth diagrams, we like orderly progressions, we like the comfort of evenly spaced milestones. But reality often develops through a blend of averages and extremes. The average may move one way while exceptional regions race ahead. If Webb is teaching us anything at the emotional level, it may be this. The beginning was not uniform enough to stay simple. That is why one record object can feel like a wound in the timeline. Not because it destroys the timeline, but because it punctures our easy version of it. It reminds us that history, even cosmic history, is not always best described by the mean. Sometimes the frontier is advanced by the outliers, by the compact bright systems that reveal what the average description was hiding. But then another question naturally follows. If the outliers are what we notice first, how representative are they? How much of the early universe was actually like this? That is where caution returns, and rightly so. Telescopes do not find typicality first, they find detectability. The objects most likely to enter the conversation are often the luminous, the compact, the fortunate, the ones whose geometry and brightness help them stand out against the noise. That selection effect does not invalidate the discovery. It simply tells us to be careful about how far we generalize from it. A remote galaxy bright enough to study is, in a sense, already biased toward being informative. And yet even that bias tells us something important. Detectability at this frontier requires real physical intensity. You cannot explain it away as mere observational luck. If an object can be found and characterized at these redshifts, then somewhere inside it there is enough structure, enough light, enough energetic activity to push back against the extreme remoteness. The outliers may not define the whole epoch, but they do define what the epoch was capable of. Capability matters. An era is not just its average state. It is also the range of things it can produce. If the early universe could already produce compact galaxies with active star formation and measurable chemical enrichment, then the era itself was more dynamically capable than a softer picture implied. That does not mean every region looked like JADES-GS-Z14-0. It means cosmic dawn included places where the machinery of structure formation had already advanced into serious work. And serious work leaves more than oxygen behind. It leaves another, quieter clue in the overall brightness and spectral shape of the galaxy. The light does not merely indicate existence. It hints at the vigor of the stars energizing the gas, at the compactness of the system, at the fact that the source is not some passive ember floating in old darkness. It is active, still making, still changing. Which leads us to one of the most striking upgrades in this whole story. The farther we follow the measurement, the less the discovery feels like we found something there, and the more it becomes, we can tell that something there was already alive with process. That is a very different kind of frontier. Because once a remote source stops being a point and starts becoming a process, you're no longer simply looking across distance. You are watching history with internal motion. Internal motion is what makes this discovery feel less like archaeology and more like witness. Archaeology, in the ordinary sense, often deals with things that have already ended: ruins, bones, pottery, civilizations whose movement is over, leaving only arrangement behind. But the light Webb is collecting from these galaxies was emitted during activity. The source was not a fossil at the moment of emission. It was a working system. Gas was still collapsing. Young stars were still flooding nearby regions with radiation. The galaxy was in the act of becoming more than it had been a short time before. That distinction matters emotionally. We are not only uncovering what existed, we are catching change in progress at a distance so great that everyday language struggles to hold it. It is one thing to know that stars must have formed early. It is another to recognize that the signal arriving now carries the signature of that formation, while it was happening in a compact galaxy near the dawn of structure. The farther you stay with that thought, the stranger it becomes. This is not like seeing a city from far away and knowing people once lived there. It is like receiving its light from an age when the streets themselves were still being laid out, while windows were already lit in the first buildings. The city is not complete, but it is already awake. That sense of wakefulness is central to what Webb has changed. Before these measurements, the earliest part of galaxy history often lived in the imagination as a zone of probable events. We had models, we had indirect constraints, we had lower redshift observations that told us what had to have happened earlier, yet there remained a thinness to the direct evidence at the most extreme distances. The first chapters were mapped in outline more than in texture. Now texture is beginning to arrive. Texture means not just a point of light, but hints about compact size, not just a redshift, but evidence of strong emission from ionized gas, not just the existence of a distant galaxy, but the possibility of estimating how energetically stars inside it are affecting their surroundings. Not just an early object, but one whose chemistry already suggests prior stellar generations. These are not minor refinements. They are the difference between seeing a shoreline in fog and beginning to distinguish houses, docks, and smoke. Once you can make out smoke, you know there is labour somewhere. And labour is the right word again here, because the beginning of cosmic light was not effortless. Star formation is a battle between gravity trying to gather gas and other processes trying to resist or disrupt collapse. Radiation from new stars can heat and ionize nearby gas. Stellar winds and later explosions can stir the medium. The compact galaxies Webb is measuring were not peaceful ornaments. They were sites where matter was being worked over by competing forces, with gravity repeatedly finding ways to win enough local battles for new stars to appear. This is one reason compactness matters so much. A small physical size does not make a galaxy unimportant. In these early systems, compactness can be part of the story of intensity. Pack enough gas into a limited region, under the right conditions, and you can get a luminous source that punches above what a casual observer might assume from its scale. That is why some of these record-distance galaxies feel almost disproportionate. They are little places doing consequential things. The deeper implication is hard to avoid. If such systems were present this early, then the opening era of structure formation was not merely a matter of the universe having time to do its work. It was also a matter of the universe finding efficient routes, dense enough halos, quick enough cooling, fast enough stellar life cycles in some environments, strong enough bursts of formation to leave measurable fingerprints across almost the whole age of the cosmos. That does not mean the young universe was crowded with brilliance. It means it had discovered the method. A town before sunrise can still be mostly dark even if the bakeries are already hot. A coastline before morning can still look black from far away even if a few harbours are already active. The general condition can remain unfinished while local engines start operating. This is the right emotional balance to keep. Webb is not showing us a fully illuminated cosmos at redshift 14. It is showing us that the machinery of illumination had already started running in some places with surprising effectiveness. The machinery matters because it helps explain why the story keeps widening from one galaxy into the larger transformation of the universe. Those early stars did not only matter for their host systems, their radiation contributed, in aggregate, to the slow reworking of the intergalactic medium. Their heavy elements began the long chemical story that later generations of stars, galaxies, planets, atmospheres, and living beings would inherit. Their existence made later complexity possible, even if they themselves remained small, hot, and short-lived compared with the grand later systems we often picture when we think of galaxies. This is where knowledge starts to deepen feeling instead of replacing it. The technical terms can be intimidating if left naked. Redshift, emission lines, ionized gas, metallicity, rhyonisation. But behind them is a very simple movement. Darkness gives way unevenly to local light. Local light alters its environment, repeated often enough, across enough space. Those local alterations accumulate into a changed universe. Webb is measuring some of the earliest known moments in that movement. And the movement is not abstract anymore. If you hold the timeline in your mind, it almost becomes tactile. The Big Bang, expansion, cooling, a long interval before stars and galaxies began to reshape the simple early composition. Then, in some lucky and dense regions, collapse, ignition, radiation, feedback, enrichment, new rounds of change. All of this still folded inside a universe that was only a few 100 million years old. It is like finding that a construction site you assumed would still be raw foundation already has internal plumbing, warm lights, and smoke from a kitchen vent. Again, not because the site is finished, because the work started sooner or moved faster in places than our intuition lets us feel. That intuitive lag is one of the hidden themes running underneath this whole subject. Perception trails reality. We build average pictures because averages are easier to imagine. We flatten uneven beginnings into smoother narratives because the mind likes gradual curves. But the universe is not obliged to be psychologically comfortable. Webb keeps reaching into regions where our summary language is too broad, and each new measurement trims away a little more of our old softness. A good example is the temptation to talk about cosmic dawn as though it were one clean threshold. In reality, thresholds smear. Different regions lit up at different times. Different galaxies formed stars at different rates. Some compact systems likely became significant contributors earlier than others. Even the transition of the wider medium out of neutrality was not an instant. It unfolded in bubbles, overlaps, and patchy progress. Dawn, in this context, was not a single switch. It was a landscape of uneven brightening, which makes the record distance measurements even more compelling, because they are direct glimpses into that landscape while it was still being shaped. We are not only looking at what dawn led to, we are looking inside dawn. The title keeps paying off because of that one preposition. At record distances would already be impressive. Star formation at record distances is much more. It gives the frontier an interior. It tells us that these are not inert markers on a cosmic timeline. They are active regions whose light carries signs of birth, excitation, and change. The edge of visibility has acquired process. That is one of the reasons the discovery refuses to stay inside astronomy. Not in the sense that it belongs to mysticism or vague inspirational language, but in the sense that it touches a deeper human tension. We live most of our lives inside late consequences, finished surfaces, stable atmospheres, mature stars, well-worked chemistry. Webb pulls perception back toward a part of reality where those later conditions did not yet exist, yet the seeds of them were already operating. It lets us witness causation near the beginning of one of the longest stories there is, and that story is still not finished revealing itself, because once you realize these distant galaxies are processes rather than points, you naturally want to know how confident we can be in what the light is telling us, and where the edge of confidence still lies. That is where frontier science becomes most honest, and often most beautiful. Not when it knows nothing, not when it claims too much, but when it can say, with growing precision, this much is firmly read from the signal, this much is the strongest interpretation, and this much remains open while the data gets better. The remarkable thing is how much of that signal is already readable. Readable enough that uncertainty no longer feels like fog over the entire scene. It feels more like the edge of a photograph, where the center is sharpened while the outer details still wait to come into focus. That distinction is essential, because frontier astronomy is often misunderstood in two opposite ways. Some people hear about a discovery like this and assume it is all speculation, a poetic guess dressed in technical language. Others hear the same discovery and treat every implication as settled fact. The truth is more disciplined than either extreme. There are parts of this story that are measured with extraordinary care, and parts that remain interpretive. The art is knowing which is which without losing the pulse of the narrative. The distance is one of the strongest pieces. Redshift is not a mood. It is a measurable displacement of spectral features caused by the expansion of the universe. When multiple facilities converge on a value this extreme, and when the signal is pinned down with increasing precision, the remoteness stops being the dramatic part and becomes the base reality. The light really did leave when the universe was less than 300 million years old. That is not the speculative portion. That is the stage on which the rest of the interpretation stands. The presence of intense activity is also not a free fantasy. A galaxy's brightness, color, and spectral behavior are not random. They are shaped by the stars inside, by the gas those stars excite, and by the way the system's light has been stretched across time. When particular emission features are indicated, astronomers are not inventing them because the story sounds better that way. They are reading patterns tied to physical processes. The difficult part is not whether physics is present. The difficult part is deciding within the allowed range exactly what combination of stars, gas conditions, and geometry best explains the signal. That is where interpretation begins. And interpretation is not weakness. It is the honest middle ground between silence and overclaiming. In a remote, compact galaxy, we may not know every structural detail. We may not know whether the source is fully typical of its epoch. We may not know the exact star formation history across every tiny region inside it. But if the data indicates strong ionized gas and energetic young stars, then the leading conclusion is not vague wonder, it is active star formation. If oxygen is detected, the leading conclusion is not decorative mystery. It is prior stellar processing. The unknowns remain, but the core of the story is already demanding. You can feel the difference if you imagine hearing an orchestra behind a wall. You may not know every instrument or see where each musician sits, but if the sound carries strings, brass, and percussion with unmistakable force, it would be dishonest to shrug and say we know nothing about what is happening in the room. The room remains unseen. The event does not remain unknown. This is why the strongest scientific storytelling is rarely the loudest. It does not need to pretend there is no ambiguity. It uses ambiguity properly, as a border around a solid center. With Webb's record-distance galaxies, the solid center is now substantial. Very distant galaxies exist. Some are compact and luminous. Some show signs of active star formation. At least one shows oxygen. These are not vague impressions. They are measurements with consequences. The consequences are what keep unfolding. One consequence is for the timeline of galaxy growth. If compact systems this early are already producing so much light, then at least some halos of dark matter must have gathered ordinary gas and turned it into stars with notable efficiency. That does not mean every region did so. It means the frontier population includes systems that got there quickly. The early universe could produce concentrated brightness sooner than a looser average picture might suggest. Another consequence touches ionization, the epoch when the first luminous structures gradually changed the state of the surrounding hydrogen gas. Ionization is often described from the top down, as a global transition in the universe, but every global transition is built out of local engines. Individual galaxies and clusters of galaxies matter because they are the sources doing the ionizing. Measuring star formation at these redshifts helps us understand not only that light existed, but what kinds of sources were available to perform that work. And then there is the chemical consequence. Oxygen at such a distance implies that some stellar generations in that galaxy had already lived and died. This does not tell us that the whole cosmos had become richly enriched. It does tell us that the chain from raw gas to stellar processing to altered chemistry had already begun in at least some places. The memory of stars was already present. When you let those consequences sit together, They form a stronger picture than any one headline could carry. The early universe was not just a remote era. It was an active environment in which some compact galaxies rapidly became meaningful agents of change. They were producing light, shaping gas, and in some cases already carrying the products of earlier stellar lives. The beginning had already acquired internal history. That phrase, internal history, may be one of the most important in this whole script. Because the true shift brought by Webb is not that the frontier moved a little farther. It is that the frontier has started showing layers. We are no longer speaking only about the first visible objects in a simple chronological order. We are speaking about objects that themselves contain sequences, episodes, and evidence of prior transformation. Even near the dawn, there was already enough time for history to start folding inside structure. That is a much richer and stranger thing to know than simple distance. It also changes how we should think about the phrase "the first galaxies." In casual language, that phrase can sound like a single category, as though the first galaxies all shared one common state and appeared cleanly at one moment. Webb's observations press against that simplicity. There were likely earlier and later firsts depending on what feature you care about. The first stars, the first small proto-galactic systems, the first sources luminous enough to see clearly, the first systems to begin meaningful enrichment, the first ones to contribute strongly to ionizing their surroundings. The frontier is not one event, it is a layered emergence. Layered emergence is harder to summarize, but it is far truer to the data. And truth like that carries a different emotional weight. It strips away the comfort of neat beginnings. It reminds us that reality usually arrives in overlapping waves. A compact galaxy at redshift 14 is not the beginning in some pure cinematic sense. It is one visible part of a broader opening process, already carrying evidence that processes had been running before the light we now see was emitted. That complexity does not reduce the wonder, it increases it. Because now the frontier is not a single bare threshold, it is a living edge. Living edge is exactly what a deep survey becomes under Webb. It is not simply a hunt for the farthest object, though records matter and the search for them has its own thrill. It is an attempt to map the edge where detectability meets origin, where the observable universe is just barely willing to disclose what its earliest major structures were doing. The farther we push, the more that edge looks not like emptiness, but like a shoreline with fires already burning along it. There is a certain humility built into this. For most of human history, the sky looked ancient in a way that could only be contemplated, not tested. The deepest past belonged to philosophy, myth, and later theory. We could reason about beginnings, but not watch them. We could imagine first light, but not isolate it in a measurable object whose spectrum told us about gas, stars, and chemistry. Webb is part of the moment when that old helplessness begins to fade. Not entirely. The frontier still resists. The first individual stars remain mostly beyond direct reach. Many interpretations remain provisional, but helplessness is no longer the right word. We can read now. Not everything. Not perfectly. But enough that the opening pages of cosmic structure are beginning to feel like documents instead of legends. That sentence might sound grand if it were not so physically literal. A spectrum is, in effect, a document written by matter interacting with light. Different atoms and ions leave distinct traces. The expansion of space shifts where those traces appear. Telescopes tuned to the right wavelengths gather them. Analysts compare what arrives with the physical behavior expected under different conditions. Out of all that patient work comes something almost intimate, a statement about a remote galaxy's inner life. And inner life is exactly what makes the story harder to forget. It is one thing to know that very distant galaxies exist. It is another to feel that one of them, impossibly far away and impossibly early, was already internally busy. Hot stars, excited gas, prior stellar generations hinted by oxygen, a compact system already changing itself. By this point, the title is paying off at a deeper level than it seemed to promise. We clicked for distance. We are being left with tempo. Because the real shock is not just that the light travelled so far, it is that while that light was being emitted, the source had already entered a cycle of making, altering, and remembering. That is what makes the beginning feel less empty than before. And once you feel that, another scale shift begins to open. If the universe could already do this less than 300 million years after the Big Bang, then the question is no longer only how far away the record holder is. The question becomes what this says about the speed at which reality learned to become complicated. Complicated is the right word, because it resists both romance and understatement. We sometimes speak as if the universe began simple, and then, much later, became interesting. That is true in one very broad sense. The earliest composition was simple. The first conditions were harsher, denser, and less structured than the later cosmos we inhabit. But simple, at the level of ingredients, does not mean slow at the level of outcome. A few ingredients can still generate a rich process if the rules acting on them are strong enough, and gravity is one of the strongest narrative engines in existence. Given slight over-densities, enough time, and the ability of gas to cool and collapse, even a chemically simple universe can find routes toward extraordinary complexity surprisingly quickly. Webb is giving that abstract idea a face. Not a human face, not even a clearly imaged galactic face in the way later galaxies can be studied, but a physical one, a compact distant source whose light says, by this moment, enough had already happened here to produce bright stars, ionized gas, and the chemical memory of previous stellar lives. That is a remarkable amount of complication for a place so near the beginning. It tells us that the gap between primordial simplicity and active structure was not as emotionally spacious as many of us imagined. You can feel that gap narrowing every time the record is translated into plain language. Less than 300 million years, 2% of the universe's current age, a light source already carrying evidence of internal processes, not just existence. Each translation removes a layer of false comfort. The beginning was not empty for long. In some corners, it became a working environment with startling speed. And speed is where our intuition continues to betray us. Not because the universe was rushing by human standards of urgency, but because our minds are poor at recognizing what fast means when the scale is cosmic. We hear millions of years and instinctively slow down. We imagine vast patience, yet massive stars live on timescales short enough to matter immensely within the first few 100 million years. Dense environments can evolve quickly enough to alter their own future conditions. A compact galaxy can move through several meaningful phases while still belonging to what we casually call the dawn of structure. It is almost like walking into an unfamiliar city at daybreak and realizing that while the streets are still mostly quiet, entire supply chains are already running underneath the calm surface. Bread has already been baked, deliveries have already been made, lights are on in buildings you thought would still be dark. The larger city is not fully awake, but enough of it is active that your original picture of the hour was wrong. That is the emotional correction Webb keeps delivering. It is not telling us the early universe looked like noon. It is telling us dawn had more going on than our sleepy assumptions allowed. This becomes especially important when we talk about how galaxies form. The simple version goes something like this. Dark matter provides gravitational scaffolding. Ordinary gas falls into those potential wells. The gas cools and condenses. Stars form, and over time galaxies grow more massive and chemically enriched. That broad outline still stands. Webb has not replaced it with some completely alien story. What the new observations do is put pressure on the tempo inside the outline. How early could those steps start? How efficiently could they proceed in favorable environments? How bright might the resulting systems become? How soon could the first cycles of stellar enrichment begin? These are not cosmetic questions. They affect how we model the opening phase of galaxy assembly, how we interpret the sources responsible for ionization, and how we think about the first transitions from pristine material into environments already marked by stellar history. In that sense, Webb's measurements are not merely extending a timeline, they are tightening causation. Tight causation is a less flashy phrase than rewriting the universe, but it is much closer to the real achievement. Frontier science earns its power through constraint. It tells theories, you must now fit this. You must produce galaxies that are not only present but luminous, compact, and physically active at these epochs. You must leave room for rapid enrichment where oxygen can already appear. You must account for a population that thins toward higher redshift. Yes, but not so brutally that the frontier becomes empty before Webb reaches it. That is where discovery starts to feel like negotiation. The universe presents the evidence. Our models have to answer. There is something satisfying in that because it restores a sense of reciprocity to science. We do not simply impose equations on the cosmos and declare victory. We build instruments, collect signals, and then reality gets a turn to speak back. Sometimes it speaks softly, through a small shift or a modest correction. Sometimes it speaks by handing us a compact galaxy from less than 300 million years after the Big Bang, and asking whether our old intuitions were ever sharp enough for the job. Usually they were not, and that is not embarrassing. It is the whole point of measurement. Human beings are not naturally equipped to picture deep time, extreme distance, or the internal tempo of early cosmic structure. We evolved to judge thrown stones, changing weather, the movement of animals, the intentions of other people. The fact that our unaided intuitions are coarse at redshift 14 is not a flaw. The astonishing part is that we have learned how to go beyond them. That is one reason the discovery carries such a particular emotional charge. It is not just a fact about the universe, it is also a fact about perception. The night sky that once looked like a decorative canopy has become a layered archive. With the right tools and enough patience, we can read from it not only distance but development, not only age but activity, not only remoteness but process. The darkness was never mute. We were simply not yet listening in the right range. And once you realize that, the telescope itself begins to feel different. Webb is often described in terms of its mirror size, its infrared sensitivity, its position in space, its technical design. All of that matters. But beneath those engineering facts is a subtler idea. It is a machine for turning ancient stretched light back into present understanding. It takes a signal that left a galaxy before the Earth existed in anything like its current state, and it helps translate that signal into statements about stars, gas, and chemistry. The machine does not create the wonder, it makes the wonder legible. Legibility is a powerful thing. A mystery that remains wholly inaccessible can inspire awe, but it also keeps you outside. A mystery that becomes partly readable invites a different feeling, not ownership, not conquest, something gentler and more durable. Participation. The sense that consciousness has managed to reach outward and make contact, however delayed and partial, with events near the opening of visible cosmic history. That contact becomes even more meaningful when we remember what has not been directly seen. Webb has not shown us the very first individual stars in some simple, cinematic sense. The first stars remain extremely difficult to isolate directly. Much of what we infer comes from galaxies whose integrated light contains the work of many stars together and the gas they affect. This distinction matters for honesty. We are not watching the entire beginning in perfect close-up. We are reading early chapters through the luminous systems that emerged from them. Yet there is no disappointment in that if you understand what is being offered. In some ways, a galaxy is an even richer witness than an individual star. It holds the collective result of star formation, feedback, chemistry, and structure building in one place. A remote compact galaxy can tell us not only that stars existed, but that stars were already numerous or energetic enough to shape a small system, and perhaps old enough in some cases to have left heavier elements behind. That is not a diluted version of the dawn, and it is a dense one. Dense is the right word again, because so much of this story comes back to concentration. Concentrated brightness, concentrated star formation, concentrated information inside faint, stretched light, concentrated implications inside a few measured lines and bands. A lot is being asked to fit into a very small box, physically and observationally, and remarkably, it does. That concentration is also why a record object can alter the emotional landscape of the whole field. JADES-GS-Z14-0 is not just another data point at the edge of a graph. It is a concentrated challenge to every lazy summary of the early universe. It says, in effect, that by this point, in at least one compact place, the machinery had already run far enough to leave behind active star formation and the chemical signature of previous stellar work. Once you hear that clearly, you cannot go back to imagining the first few 100 million years as a politely empty prelude. They were a beginning, but they were not waiting around to become one. And that realization naturally pushes us outward again, away from the single source and back toward the larger universe it belonged to. Because once local complexity appears this early, the question is no longer only how one galaxy evolved. It is what kind of cosmos could produce such islands of acceleration while still remaining, in the large view, unfinished and dark. That combination, islands of acceleration inside a still unfinished cosmos, may be the most honest image of cosmic dawn we have. It preserves the darkness without exaggerating it into emptiness. It preserves the surprise without turning it into theatrical impossibility. It lets the early universe remain what the evidence suggests it was, a place where most of space had not yet been transformed. Yet some compact regions were already doing the hard work of transformation. Not symbolism, not metaphorical awakening, actual physical change, gas collapsing, stars igniting, radiation escaping, chemistry shifting. Small systems becoming consequential. Once you accept that balance, the larger universe becomes easier to picture. Imagine a vast cold sea before sunrise, almost entirely black, with scattered points where fires have begun to burn along the shorelines of islands. The sea as a whole is not yet bright. Most of the horizon remains unlit, but the fires are real, and each one changes its local environment, their heat, their smoke, their glow, their expanding influence all matter. Given enough time, enough islands, and enough overlap, the entire character of the scene changes. That is close to what reionization means at the level of feeling. Not a global switch flipping all at once, but an immense patchwork transition built from local sources of light. The compact galaxies Webb is measuring are not spectators to that event. They are among its agents. That is why measuring star formation at these distances matters more than simply cataloguing remote objects. If you want to understand how the universe changed from a mostly neutral medium into one that allowed light to travel more freely, you need to know what kinds of galaxies existed, how many there were, how bright they were, and how energetically they formed stars. You need to understand whether early structure was timid or effective. The record sources matter because they help answer the question of effectiveness. And the answer, so far, is that at least some early systems were surprisingly effective. Not grand in the way a later mature galaxy can be grand, not huge, not serene, effective in a narrower, harsher sense. They could gather matter, turn it into stars, and generate observable signatures of intense activity very early. They could begin to alter their own gas and perhaps the gas around them. They could become visible across almost the full span of cosmic history. They could, in at least one case, already carry oxygen. That is enough to make the entire early universe feel more operational than ornamental. Operational is not a word people usually bring to the night sky, but it fits. It reminds us that stars are not just beautiful from a distance. They do things. They generate pressure. They emit energy. They create heavier elements. They shape surrounding matter. In cosmic dawn, those functions were not background details. They were the beginning of a new regime. The first sources of sustained light were not merely appearing, they were getting to work on the universe. That phrase can sound almost too human, but it helps because it resists another common drift in this topic, the drift towards smooth abstraction. When language gets too abstract, the beginning of the universe can turn into a sequence of labels: recombination, dark ages, first light, reionization, galaxy assembly, all accurate, all useful, and all in danger of becoming emotionally flat if left unattended. What Webb restores is not just more information, but a sense of labor inside those labels. Matter did not simply progress, it underwent repeated contests, thresholds, and transitions. Compact galaxies at record distances are where those abstract phases begin to feel physical again. The force of this becomes even clearer when we remember how much was still absent. There were no old spiral disks stretching in majestic calm across hundreds of thousands of light years. No mature galaxy clusters with long-settled populations. No planets like Earth. No forests, no oceans, no biology. No atmosphere filled with later chemistry. The universe, in the ordinary sense of habitability or familiarity, was profoundly incomplete. And still, inside that incompleteness, there were already sites dense and bright enough to produce the kinds of signatures we can now read as active star formation. That is one of the deepest emotional inversions in the whole story. We're used to thinking that complexity belongs mainly to the late universe, to the long aftermath of countless prior cycles. But Webb is showing that complexity began establishing footholds very early. Not the full spectrum of later complexity, of course, not life, not planets, not calm mature structure, but the kind of astrophysical complexity that makes all later things possible, had already started taking hold. A foothold is the right image, not yet a continent, not yet stable everywhere, but enough purchase for the climb to continue. And once that idea of footholds enters the mind, the title starts sounding almost understated. James Webb just measured star formation at record distances. Yes, but what that really means is that human beings have acquired a new kind of access to the first footholds of cosmic complexity. We are no longer limited to saying that the early universe must eventually have produced stars and galaxies. We can now point to specific systems and say that by this time, in this compact place, active star formation was already underway and leaving measurable evidence behind. That sentence may not sound dramatic in the exaggerated way modern headlines often try to sound, but its restraint is part of its power. It is a sentence of contact, specificity, presence. It says the beginning is not only inferable, it is partly observable in action. Still, the larger cosmos around these objects must not disappear from view. One of the risks of a striking frontier source is that it can dominate imagination so strongly that we forget the environment it emerged from. JADES-GS-Z14-0 is compelling precisely because it sits in tension with that environment. The young universe was still a difficult place for light. Neutral hydrogen still mattered. Transparency was incomplete. Cosmic structure was young. The source is informative because it is a compact success inside a wider unfinished state. This tension between local success and global incompletion is not a side note. It is the whole rhythm of early history. The first galaxies did not emerge into a universe already ready for them. They helped make it ready. Their light did not merely travel through conditions. It helped transform conditions. The compact sites Webb studies are therefore not only products of cosmic history, they are contributors to it. That is an enormous conceptual reward hidden inside a seemingly technical measurement. A star-forming galaxy at record distance is not just a marker on the way to later things. It is one of the places where later things begin to become possible. Its stars are part of the effort that remade the larger medium, seeded later chemistry, and established pathways of structure that would continue for billions of years. And because the larger medium still mattered, the act of detecting such a source becomes even more impressive. We are reading a signal born in a compact energetic system, emitted into a young cosmos that was not yet fully transparent, stretched by the expansion of space across billions of years, and finally gathered by a telescope built by a species that arrived much later on a small rocky world orbiting an ordinary star. There is no need to add drama to that chain. It already contains more than enough. If anything, the proper response is slower and quieter than hype. You let it settle. You notice how many steps had to align. Physical laws allowing structure to grow. Early regions dense enough to collapse. Stars massive enough to live fast and shape their surroundings. Galaxies compact enough and bright enough to stand out. Light surviving the journey. Engineers building the telescope. Analysts interpreting the data carefully. Each link is ordinary in its own domain. Together, they form something close to a miracle of legibility. Not a miracle in the supernatural sense, a miracle in the sense of improbable coherence. The universe is not required to be readable by creatures like us, and yet, to a remarkable degree, it is. That fact begins to change the emotional color of uncertainty itself. Unknowns remain. The exact distribution of the earliest star-forming galaxies is still being refined. The first individual stars remain elusive. Sample sizes at extreme redshift remain limited. Selection effects remain important, but the unknown is no longer an empty wall. It is a receding frontier with real shapes already visible along its edge. Uncertainty has become textured. Textured uncertainty is much easier to trust than vague mystery. It invites patience instead of fantasy. It lets you say, honestly, here is what we know, here is what we strongly infer, and here is what the next observations may sharpen. It keeps wonder alive without dissolving into nonsense. And that is exactly the tone this subject deserves, because reality at this scale is already more than rich enough. There is another quiet lesson here as well. The early universe did not need enormous maturity to become interesting. It only needed enough asymmetry, enough gravity, and enough time for the first local engines to ignite. That is a useful correction to the way we think about complexity in general. We often wait mentally for the later, larger, more obvious stages before granting a process its full significance. Webb reminds us that the first compact footholds can matter immensely. A small system, early enough, can change the meaning of an era. That may be the deepest reason this discovery lingers. It is not just about distance. It is about how quickly significance can appear. And significance, once it appears, keeps unfolding, because after distance, time, star formation, compactness, and oxygen, a final perception shift begins to take shape. The old night sky above us, so familiar it can almost disappear into routine, is not only full of remote objects, it is full of delayed beginnings. Delayed beginnings are one of the strangest things a mind can hold without fully grasping. We know, in the abstract, that astronomy looks into the past. The phrase is repeated so often it risks becoming a slogan. But once Webb reaches into the first few 100 million years, that old idea starts to recover its force. The sky stops being a single present scene and becomes a stack of different eras arriving together. Nearby stars belong to one age. More distant galaxies belong to another. The record holders belong to an age so remote that even the word ancient becomes slightly clumsy. Because what we are seeing is not ancient in the sense of worn out. It is ancient in the sense of newly begun. That is a difficult reversal, and a beautiful one. The oldest light can come from the newest structures. You can feel the paradox in your own body if you imagine standing under the stars and trying to assign emotional categories the way everyday life teaches you to do. Far means old. Old means settled. Settled means quiet. But Webb reaches out to places where far means early. And early does not mean quiet. Early means gas collapsing, stars igniting, radiation bursting into surrounding hydrogen, local chemistry already beginning to change. The remoteness suggests stillness. The reality suggests momentum. Momentum is why this whole subject remains so absorbing even after the headline fades. A single, farthest galaxy story can feel like one more number in an endless ladder of bigger and farther records. But when the signal begins to reveal process, the record acquires interior tension. This is not just the farthest confirmed galaxy. It is a place whose light says that by then, in at least one compact pocket of the universe, events were already moving fast enough to leave physical traces we can study now. That means the night sky contains motion hidden inside delay. There is something emotionally exact about that. So much of human life works the same way in smaller forms. We meet people long after their beginnings have shaped them. We inherit cities built by decisions made before our time. We live inside consequences whose causes are old and still active inside the present. Webb takes that ordinary truth and stretches it to cosmic scale. The light arriving now is not the source itself as it is now, whatever now would mean across such distances. It is a consequence carrying active history inside it. And because the light is delayed, what we know of those galaxies is always entwined with the fragility of perception. We never see them directly in the simple sense. We never stand near them. We never watch them minute by minute. Everything depends on signal, on photons gathered after unimaginable travel, on the discipline of teasing information from faint patterns, on the refusal to confuse what is measured with what is merely imagined. That fragility does not weaken the discovery. It gives it dignity. It reminds us that knowledge at the frontier is not possession. It is contact achieved under difficult conditions, a careful reading in near darkness. And when the reading is done well enough to tell us that a compact galaxy less than 300 million years after the Big Bang was already actively forming stars and already showing signs of earlier stellar processing, the result lands with a different kind of authority. Not the authority of certainty without limit, but the authority of something hard-won. Hard-won knowledge changes the emotional tone of wonder. It makes awe quieter, less theatrical, more durable. You do not need to keep saying that the universe is amazing when the evidence itself has begun to rearrange your sense of time. You simply follow the chain of consequences and feel ordinary perception become inadequate. For most of our lives, the sky above us becomes background. Even people who love astronomy can fall into the habit of seeing stars and galaxies as symbols, rather than as specific physical realities in different stages of development. A bright star becomes just a star. A faint smear becomes just a distant galaxy. Webb resists that flattening. It forces specificity back into the heavens. This source is from here in the timeline. This light left then. This spectrum implies these conditions. This oxygen means earlier stellar lives. the sky stops being decoration and becomes evidence again. Evidence of a beginning that was more quickly eventful than we knew. And once that lands, even the familiar phrase, the early universe, starts to feel too broad to be left untouched. It can no longer mean simply a younger version of the cosmos in a vague chronological sense. It has to carry texture. Some regions still dark, some already bright, some galaxies only beginning to assemble, some already compact and luminous enough to measure, some likely close to pristine, some already carrying oxygen. Averages still useful, but less emotionally authoritative than the lived patchiness of the data. That patchiness matters beyond astrophysics, because it is another lesson in how reality often develops, not by smooth general change alone, but by uneven breakthroughs inside broader unfinished conditions. Some places race ahead, some remain in waiting, some become agents of transformation long before the larger environment has fully changed around them. It is true in cities, in ecosystems, in technologies, in social systems. And at a much deeper level, it appears to be true in cosmic history as well. This does not make the universe human. It makes certain forms of emergence feel more familiar. The familiar part, though, should not make us miss the scale of the unfamiliar. The galaxy at the center of this story is not just far in the sense that light took a long time to arrive. Because of cosmic expansion, it belongs to a universe whose geometry and scale relations were drastically different from the late cosmos we know. Everything about the setting is alien. The young age of the entire universe, the state of the surrounding medium, the smallness and intensity of the source, the absence of later structures, the relative lack of chemical enrichment on average. We are not peering across an ocean to a city much like our own. We are reading a signal from an epoch when reality itself was arranged under more primitive terms. And yet the signal is legible enough to tell us that some of the most important later processes had already begun. This is where the script's deeper thesis comes fully into view. The discovery is not mainly proving that telescopes can see very far. It is proving that complexity began earning a foothold earlier, and in some places faster, than our softened intuitions allowed us to feel. The timeline of cosmic growth has not been shattered into chaos. It has become less roomy, less forgiving of delay, more insistent about the efficiency of certain early pathways. That is a very powerful kind of correction. It takes a period many people imagine as nearly featureless, and returns to it urgency, labour, and sequence. It tells us that by the time this light was emitted, the universe had already moved from simple ingredients toward compact engines of change. Not everywhere, not completely, but undeniably. And there is something almost moving about how modest the raw evidence can look compared with the scale of what it means. A few bands of light, a redshift measurement, emission features, a line from oxygen, tiny signals in carefully gathered data. From those narrow channels comes a widened reality. It is as if the universe were whispering through a crack in a door, and from that whisper, we can tell that rooms have already been furnished inside. The whisper is enough. In fact, it has to be enough, because that is how the frontier works. We do not get total access. We get traces strong enough to build a truthful picture, and weak enough to preserve humility. That balance is one reason frontier astronomy can feel so mentally cleansing. It refuses both arrogance and despair. It says, the universe is difficult to read, but not unreadable. Our view is partial, but not empty. We are late, but not too late to understand something about the beginning. Late, but not too late. That may be one of the lines that lingers after all this is done. Because there is real luck in our position. We live in a universe old enough for complex observers to exist, yet transparent enough, structured enough, and lawful enough that those observers can look backward and recover parts of the opening story. We arrived long after cosmic dawn, but not so long after that its traces are gone beyond recovery. The first major chapters still leave light for us to catch. And James Webb, in its patient way, has begun catching that light strongly enough to show us that the first pages were already crowded with effort. Which leaves us with a final widening question. When a species on one small world can measure star formation near the beginning of cosmic history, what does that do to the meaning of an ordinary night? It makes the ordinary night harder to call ordinary. Not because every star above you suddenly becomes a dramatic symbol, and not because the sky turns into a sermon about human significance. The change is quieter than that. It is a change in texture, A familiar darkness that used to feel mostly decorative now carries depth, delay, and hidden process. You look up and know that some of the faintest reachable sources are not simply distant decorations but messages from a time when the universe was still inventing the first durable forms of complexity. That knowledge does not make the sky less peaceful, it makes the peace more layered. A good scientific discovery often works like that. It does not replace calm with noise, it replaces flatness with structure. Once you know what Webb has begun to measure, a blank stretch of night is no longer blank in quite the same way. It becomes an archive of departures, some light left recently by cosmic standards, some left before mammals, some before Earth existed, some from galaxies so early that the stars inside them were among the first known efforts by the universe to move beyond raw simplicity into active, self-changing structure. And because this is a story about measurement rather than pure imagination, the effect lingers differently. It is one thing to romanticize the stars. Human beings have always done that. It is another to know that a machine made by our species has actually extracted evidence of star formation, ionized gas, and oxygen from a source whose light has been traveling since the cosmos was less than 300 million years old. That is not romance. That is contact. Contact alters routine. It means that even if you are tired, even if the night is quiet, even if the sky above your house is partially washed out by streetlights, the old divide between everyday life and the deep universe is not as complete as it once felt. We are still small, still local, still attached to one narrow biosphere on one planet. But our perception is no longer confined to what our bodies evolved to handle directly. We have built extensions of sight that reach toward the opening phases of cosmic history and return with legible traces. There is something deeply human in that, and not in a flattering way only. It also says something about our dissatisfaction with surfaces. We do not simply live under the sky. We ask what it is. We ask when its light began. We ask what the faintest source was doing when that light left. We asked whether stars were already forming there, whether gas had already been ionized, whether oxygen had already appeared. We keep asking until the darkness gives us structure in return. That persistent asking is part of the emotional core here, because the discovery is not just about the young universe moving quickly. It is also about us refusing to remain limited to a shallow version of the sky. The night presents itself as beauty. Science insists that beauty must also have a history. And history, once recovered, changes feeling. This may be why the story keeps circling back to the same tension. Distance versus process. On the surface, faraway galaxies can seem remote enough to be emotionally weightless. They're too distant to affect daily life, too old to relate to, too abstract to become intimate. But the moment process enters, star formation, radiation, enrichment, the changing state of gas, the emotional distance shortens. Not because the object comes physically closer, but because activity is always easier to feel than mere location. A place that is doing something enters the mind more fully than a place that only exists. That is exactly what Webb has given us at record distances, not just faraway objects, but active places. Once a remote source becomes an active place, the imagination can finally meet the data halfway. You can begin to feel the compactness of the galaxy, the intensity of its young stars, the surrounding gas made luminous by radiation, the possibility that earlier massive stars had already lived and died there. Returning oxygen to the medium, you're still dealing with inference, still respecting uncertainty, but you're no longer staring at a number alone. You're standing before an event stretched across impossible distance. And that brings us very close to the deepest payoff of the title. Webb did not merely find farther, it measured becoming. That is the phrase I keep coming back to. Measured becoming. Because the most surprising thing here is not sheer remoteness. It is that the remoteness contains active growth. We are not only seeing where the universe had gotten to by then, we are seeing that in at least some compact regions, it was already vigorously on its way toward everything that would come later. Stars were already running. Chemistry was already changing. The first footholds were already being secured. Those footholds matter because they rescue the beginning from abstraction. Cosmic dawn is a beautiful phrase, but if it remains only a phrase, it can float too far above the evidence. Webb pulls it down into physical reality. Dawn becomes small galaxies. Dawn becomes hot young stars and ionized gas. Dawn becomes compact regions, bright enough to measure. Dawn becomes oxygen appearing shockingly early in one remote source. The metaphor yields to the mechanism, and the mechanism turns out to be more emotionally powerful than the metaphor ever was. This is what the best science does. It takes an idea that sounds grand in language and gives it edges, temperatures, timings, and consequences. It makes the thing harder to misuse and harder to forget. Still, there is a final caution that belongs near the end, not because it weakens the story, but because it completes it. We should not let one extraordinary object flatten an entire epoch into a single image. The early universe was not one compact luminous galaxy repeated everywhere. It was a broad developing landscape with different conditions, different rates, different levels of brightness and enrichment. The most detectable sources can skew our first impressions. Outliers arrive loudly. Averages take longer to learn. Future observations will keep sharpening that balance. But even with that caution, the essential perception shift remains untouched. The young universe was already capable of more than our casual intuition prepared us for. Some places assembled stars quickly. Some generated light intensely. Some altered their own chemistry early. Some participated in transforming the wider medium while the cosmos as a whole was still in a profoundly unfinished state. That is no longer merely a theory in outline. It is a measured reality in parts. Measured reality in parts is enough to change the whole. It changes the meaning of a record distance. It changes the emotional weight of the first few 100 million years. It changes the night sky from a mural into a timeline with active chapters. And maybe most of all, it changes what early feels like. Early no longer means nearly empty. Early now includes compact brilliance, local urgency, and the first quick memories written into gas. The gas remembers. The light carries that memory. We arrive very late and still manage to read it. That is one of the most beautiful asymmetries in science. The event happens long before us. The understanding happens now. Across all that delay, something survives. A pattern in wavelengths, a stretch in the spectrum, a line from oxygen, enough to tell us that a remote galaxy, when the universe was less than 300 million years old, was not waiting to become history. It was already making it. And perhaps that is the cleanest way to leave this part of the journey. The beginning was not a blank, it was a workshop, small in places, harsh in conditions, mostly surrounded by darkness, but already full of labour. Webb has reached far enough to show us sparks from that workshop still arriving. Once you know that, the sky above your head is no longer just overhead. It is late light from unfinished mornings, and unfinished mornings are often the most revealing because they contain both what has happened and what has not happened yet. That is the emotional position Webb places us in. We are looking at a universe that, from our point of view, was unimaginably early, and yet from its own point of view was already in motion. Enough had begun that light was no longer rare in an absolute sense. Enough remained unfinished that each compact galaxy stood out against a background still defined by incomplete transformation. The result is a kind of layered tension that the mind does not naturally invent on its own. The cosmos was both young and already busy, both dark in the large view and locally bright, both chemically simple on average and, in some places, already altered by stellar life. That layered tension is what keeps this discovery from settling into a simple lesson. If all Webb had shown us was that the first galaxies existed right on schedule, the result would be valuable but emotionally narrow. If it had shown us a fully mature universe absurdly early, the result would be dramatic but almost too clean, too cinematic to feel real. What it is actually showing is better. A frontier where some early systems seem more effective, more luminous, and more chemically progressed than older comfort allowed. While the overall universe still retains its unfinished character, reality keeps its complexity, the story keeps its credibility. There is a reason that kind of credibility feels so satisfying. We are living in an age flooded with language that tries to make everything sound bigger than it is. Every discovery must supposedly change everything. Every measurement is sold as a final answer. Every anomaly is rushed toward myth. Webb's best results do the opposite. They become more impressive the more carefully they are stated. A compact galaxy less than 300 million years after the Big Bang. Strong evidence of active star formation. Signs of ionized gas. Oxygen already present. A population of remote galaxies that thins toward earlier times, but does not disappear as quickly as simpler intuition might expect. None of that needs inflation. Each piece strengthens the others naturally. And the natural strengthening is what gives the whole subject such calm force. You do not need to be pushed into awe. The data escorts you there. That escort has one more important destination. Up to now, we have been mostly following the logic from the outside in. The age of the universe, the distance of the source, the signatures in the light, the consequences for star formation and chemistry. But there is another way to feel what Webb has changed, and it begins from the inside out. Start not with the universe, but with a human mind under a night sky, carrying a rough idea of beginnings. Then slowly replace that roughness with better contact. Replace the idea of a long dim waiting room with a patchy field of early labour. Replace vague dawn with measurable processes. Replace farther away with earlier and already active. By the end, the transformation is not only in cosmology, it is in perception itself. That may be why these discoveries matter even to people who will never read a scientific paper about them. They recalibrate ordinary thought. After this, the beginning is no longer a soft abstraction. It becomes a time when compact galaxies were already collapsing gas into stars and already writing the first chemical notes of future complexity into their surroundings. That is a new mental image available to anyone willing to sit with it. And it is a better image than the one it replaces, because the older image, for all its simplicity, made the early universe emotionally flat. It left too much time feeling like prelude, too much darkness feeling like absence, too much of the first few 100 million years compressed into a generic idea of not yet. Webb is correcting that, not by denying the darkness, but by showing what the darkness contained. Not by pretending the beginning was crowded and mature, but by revealing the compact islands where important things were already underway. That phrase again, underway, it may be the quiet centre of the entire script. A lot of scientific communication fails because it gives people static nouns when what they really need are active verbs: galaxy, redshift, oxygen, dawn. These are useful words, but they can sit too still in the mind. Webb gives them motion. A galaxy becomes a site of ongoing formation. Redshift becomes stretched travel across expanding space. Oxygen becomes the residue of earlier stellar deaths. Dawn becomes a patchwork of bubbles, light, and changing gas. The universe stops being a diagram and becomes a process. A process can be felt. You can feel it in the image of compact star-forming knots surrounded by gas they are already exciting with radiation. You can feel it in the idea that a very massive star may live only a short cosmic moment before dying and returning new elements to the medium. You can feel it in the cumulative labour of many such stars helping to reshape the wider hydrogen fog that once filled so much of the young universe. By the time those feelings settle, the discovery has moved beyond distance into consequence. And consequence is where meaning often hides. Not in slogans about how small we are, not in vague speeches about cosmic beauty. Meaning here comes from a more precise place. We now know that the universe began building complexity earlier, and, in some locations, more efficiently than many casual intuitions would have guessed. We also know that a later rising species on a minor planet has managed to recover part of that truth from stretched light. Those two facts belong together. The early universe became active quickly. We became perceptive slowly. Somewhere between them, across billions of years, lies the entire arc of this story. There is a kind of elegance in that asymmetry. The stars in a record-distance galaxy may have formed and died long before our world took shape, yet their altered light still arrives at a moment when we are capable of reading it. A compact galaxy near the dawn of structure leaves behind a delayed report, billions of years later, on a planet built from the long chemical aftermath of many other stars. That report is finally opened. The distance is real, so is the connection. That connection does not make us central. It makes us included. Included in the sense that the story of cosmic structure is not fully sealed off from the beings who arrive late. Included in the sense that the laws shaping the first galaxies are the same laws whose long consequences eventually produced chemistry, planets, atmospheres, biology, and cognition. Included in the sense that our knowledge is not separate from the universe's history, but one of its latest expressions looking backward. Again, this is not sentimental. It is simply what the evidence implies when you let it widen far enough. The the same general process of stellar creation and enrichment that began in compact early galaxies eventually becomes the deep background condition for worlds like ours. The oxygen in your lungs is not descended from that one record galaxy, of course, but it belongs to the same grand sequence, the same long traffic between stars and gas, death and reuse, light and chemistry. Webb is not just showing us something remote, it is showing us an earlier part of a process whose late consequences we inhabit. That is why the result lingers after the technical details blur. Most people will not memorize the exact redshift or remember every observational nuance. What stays is the altered intuition. The universe did not spend its first few 100 million years in simple silence. Some parts were already building, already burning, already changing the material around them, already leaving traces we can now measure. That perception, once acquired, is hard to lose. And losing it would mean returning to a flatter sky. A flatter sky is easy to live under. It demands less. It lets stars remain anonymous and beginnings remain vague. But it also leaves wonder cheap, because cheap wonder thrives on not knowing enough. The stronger kind of wonder is slower. It survives contact with detail. It deepens when phrases become measurements and measurements become process. Webb gives us that stronger kind, a wonder sturdy enough to survive precision. Precision is what carries us through the final stretch of this journey. Precision about what is known. Precision about what remains uncertain. Precision about the difference between detecting a source and inferring its internal conditions. Precision about the role of outliers, the importance of sample size, the patchiness of reionization, the early but not universal onset of enrichment. All of this keeps the story disciplined. And discipline, here, is not the enemy of feeling. It is what allows feeling to last. Because what really stays with you after all of this is not simply that the universe is vast or old or mysterious. Those are true, but they are too generic to hold the particular force of this discovery. What stays is more specific. The beginning had tempo. The darkness had work inside it. Some of the first compact galaxies were already doing enough that their light, stretched and delayed across nearly the full history of the cosmos, still carries the marks of becoming. Marks of becoming, that is what Webb is reading at record distances. And once you realize that, the distance itself starts to feel secondary, still staggering, still beautiful, but no longer the deepest point. The deeper point is that the universe was already becoming more than its raw ingredients astonishingly early, and that this becoming was strong enough to be measured now by us, in the late quiet of a much older cosmos. In the late quiet of a much older cosmos, that may be the most disorienting part to hold on to. We live so deep into the story that the beginning can seem unreal by comparison. Our world feels complete in the way local things always do. The ground is firm, air is breathable, chemistry is abundant. Stars rise and set with enough regularity that we use them to measure time, not to question where time itself once began to gather shape. Most days, reality arrives already assembled. Webb disrupts that comfort without making it cruel. It reminds us that the assembled world is late, very late. And when it reaches toward galaxies whose light left less than 300 million years after the Big Bang, it shows us a universe that had not yet become familiar, yet was already becoming consequential. There is a difference between those two states. Familiarity is what later ages feel like from the inside. Consequence is what early ages can already carry before anything like familiarity exists. That is the true drama of this discovery, not spectacle, sequence, not the loud claim that everything was already complete near the beginning, but the much more interesting fact that enough was already underway to matter profoundly. Compact galaxies were already forming stars. Hot young stars were already energizing gas. Earlier stellar lives had already, in at least one known case, left behind oxygen. A universe still mostly unfinished had already started writing the rules of its later complexity into matter. And all of that survives in the light. A photon leaving such a galaxy does not know it is evidence. It simply travels. It crosses an expanding universe. Its wavelength stretches. The conditions around it change epoch after epoch. Galaxies merge. Stars are born and die. Planets form. On one small world, life appears, evolves, becomes reflective, becomes restless, learned optics and detectors and the mathematics of spectra. The photon keeps going. At last it meets a mirror, a sensor, a chain of analysis. What began as emission in a compact early system ends as understanding inside a much later mind. That chain is one of the quiet miracles of science. Again, not supernatural, just improbable in the deepest material sense. The universe is not merely happening. It is leaving traces detailed enough that entities produced by much later chapters can reconstruct something about the opening ones. The beginning does not stay sealed. It leaks forward in light. That leakage is what makes the night sky an instrument as much as a view. We do not stand beneath a ceiling of ornaments. We stand beneath arrivals. Some of them carry shallow delays by cosmic standards. Some carry deep ones. Some carry signals from structures so early that the ordinary human categories of youth and age begin to twist around each other. The oldest arriving light can reveal places that were themselves newly active. That paradox is not a trick of language. It is built into the geometry of the observable universe. And once you grow used to that paradox, another feeling begins to take shape. Gratitude. Perhaps. Though even that word can sound too soft or too moralized. Luck may be better. We are lucky to live at a time when the tools exist. Lucky that the laws of light and matter allow this kind of reading. Lucky that the early universe did not hide its first compact luminous systems completely beyond reach. Lucky that some of the first major episodes of star formation were forceful enough to leave recoverable signs. Lucky that enough of cosmic history lies behind us for observers to exist, and not so much lies between us and the beginning that every trace has become unreadable. Luck is not the whole story. Of course. None of this happens without labour. Generations of engineers, theorists, observers, analysts, decades of patient work, institutional persistence, failures, redesigns, launches, calibrations, arguments, revisions. Human beings do not stumble into measurements like this by accident. We prepare for them. But preparation alone does not create a readable universe. It meets one. That meeting is why the result feels larger than a telescope story. Telescopes are tools. What matters is the encounter they make possible. Here. The encounter is with a moment in cosmic history when simplicity was already giving way to local complexity far sooner than many people would naturally imagine. Webb did not create that truth. It created access to it. And access changes not only what we know, but the emotional scale at which we can know it. For most of human existence, the beginning was either sacred narrative, philosophical speculation, or mathematical reconstruction, all powerful in their own ways, all distant from direct witness. Now the category has shifted, not entirely. We are still far from total access. Much remains inferred, many details remain contested or unresolved, but the shift is real. Parts of the beginning are now observable as measured consequences in specific objects. That is a civilizational change in perception, whether or not we speak about it that way in daily life. You can almost feel the old boundary dissolving. There was a time when the earliest galaxies belonged emotionally to the same realm as myth, not because science confused them with myth, but because they were too remote for most people to feel as anything but abstraction. Webb breaks that spell. It does not remove mystery. It removes vagueness. The earliest observable structures begin to take on names, inferred sizes, spectral fingerprints, chemical hints. They enter the same universe of evidence as everything else we study. And because they enter that universe of evidence, they become harder to sentimentalize badly. That is a gift. It saves us from lazy cosmic language. It saves us from pretending that awe requires fog. The stronger awe comes when you can say exactly why something matters. Less than 300 million years after the Big Bang, a compact galaxy bright enough to study, strong signs of active star formation, oxygen already present, a beginning that had already developed internal history. Those are precise statements. Together they produce a much deeper feeling than generic grandeur ever could. By now, the title has unfolded almost completely. James Webb just measured star formation at record distances. We began by hearing that as a triumph of reach, then it became a triumph of timing, then of process, then of chemistry, then of perception. Each step made the one before it heavier. Distance mattered because it meant early time. Early time mattered because stars were already forming. Star formation mattered because it meant radiation, change and the beginning of environmental transformation. Chemistry mattered because it meant prior stellar generations. Perception mattered because it meant a late species could recover all of this from delayed light. That is a full arc, and it does not need embellishment. What it does need, right before the end, is one final widening of scale, not back toward abstraction, but toward proportion. The record-setting objects are easy to focus on because records are memorable, yet the true significance lies not only in the individual champion, but in what the champion reveals about the era. It reveals that the young universe, while still largely dark and incomplete, was already capable of producing compact luminous systems whose internal activity can be measured. It reveals that the opening phase of galaxy growth included efficient pathways. It reveals that the first great transformation of the cosmos was built from local engines that started running early. And once you see the era in those terms, a final realization settles in. The universe did not become meaningful only after it became familiar to worlds like ours. Meaningful things were already happening long before there was anyone to witness them. The first compact star-forming galaxies were already changing the state of reality while no eyes existed to see it. Their work was not waiting for observers to matter. It mattered first. Observation came later. That order is important. It protects the story from human vanity. We are not the purpose of the beginning. We are one of its late consequences. Yet the late consequence has acquired the ability to look backward and understand some of the earlier labour. That is enough. More than enough. So when the script finally closes, I do not think the image that remains is one of pure distance. It is something quieter. A small bright system in a mostly dark young universe, already hard at work. Radiation pouring into nearby gas. Heavy elements beginning to appear. Light leaving that place and travelling for more than 13 billion years. Then, at last, arriving here. And here is the part that lingers. When you look up now, the sky is no longer just a display of what is out there. It is a record of how quickly the universe learned to start over and over again from simple beginnings. Not everywhere at once, not smoothly, not gently, but effectively enough that, astonishingly early, some corners of reality were already full of fire. That fire is still reaching us. It crosses the age of the universe to tell us that the beginning was not empty, not silent, and not patient in the way we once imagined. It was already building, already burning, already remembering. And we arrived late enough to call it history, but not too late to see the light. That may be the luckiest fact in this entire story. We arrived late enough to inherit a universe rich with old stars, heavy elements, planets, weather, oceans, and the long chemical aftermath of countless earlier cycles. But we did not arrive so late that the first major awakenings of structure had vanished beyond all recovery. Their light is still in transit, their signatures are still legible. Their work, done in compact galaxies near the dawn, still leaves enough pattern in what reaches us that we can say something honest about what those places were doing. And what they were doing was not trivial. They were taking a universe that began with very few ingredients and pushing it toward consequence. They were turning gas into stars. They were flooding nearby space with radiation. They were beginning, in at least some cases, to alter their own chemistry through the short, bright lives of massive stars. They were helping to change the larger medium from which later cosmic history would emerge. The beginning was not a blank corridor leading passively toward later beauty. It was already full of labour. Once you let that settle in, a strange calm comes over the whole subject. The discovery no longer feels like a headline trying to impress you. It feels like a correction to the inner picture you carry of reality. The old version says the early universe must have been mostly empty and slow, with the interesting parts belonging to much later chapters. The better version says the early universe was indeed sparse and unfinished, but some parts of it were already intensely active, already beginning the long work from which everything more familiar would eventually descend. That distinction matters because it restores dignity to the first few 100 million years. It stops treating them as dead prelude. It lets them become what the evidence suggests they were, a time of uneven ignition, compact brilliance, and the first fast loops of stellar cause and effect. Not mature in the later sense, not hospitable, not stable, but undeniably in motion. And motion is what changes the way we feel time itself. We usually think of the deep past as static because it is over. We imagine old things as frozen in the way photographs are frozen. Webb breaks that habit. It forces us to recognize that some of the oldest arriving light comes from places that were not static at all when it left. Those galaxies were in the act of building themselves. Their stars were not museum pieces. Their gas was not resting. Their chemistry was not finished. We are receiving motion in delayed form. That is one of the most beautiful scientific ideas a person can carry around. The cosmos does not only preserve old states, it preserves old processes. And when you realize that, the night sky above you becomes more than scenery. It becomes a field of delayed verbs: burning, forming, stretching, collapsing, enriching, traveling. The stars and galaxies overhead are not only nouns pinned to darkness, they are histories still arriving, some shallow, some impossibly deep. Some of the faintest reachable sources are carrying news from an age when the first compact engines of change had already started running. This is where the feeling of scale changes one last time. At the beginning of this journey, the scale was mostly outward, distance, age, redshift, all of it expanding away from human proportion. But by the end, the scale folds inward as well. The question becomes not just how far Webb can see, but what kind of mind can absorb what it finds. How do you hold a reality in which the universe was less than 300 million years old, and yet already contained compact galaxies whose light reveals active star formation and signs of previous stellar generations? You do not really master that fact. You live beside it. You return to it. You let it work on your intuition slowly. That slow work is important. Some discoveries hit fast and fade fast. This one is better than that. It is not merely shocking, it is restructuring. It reaches into one of the oldest assumptions people carry about beginnings, that beginnings are mostly simple, mostly quiet, mostly waiting, and it leaves that assumption weaker than it was. In its place, it offers something more truthful and more interesting. Beginnings can be patchy, urgent, and locally efficient. They can be unfinished in the large view while still full of decisive activity in the small one. They can contain the seeds of later worlds long before anything like those worlds exists. And because of that, the discovery lands with emotional force without ever needing to become melodramatic. There is no need to pretend the universe was secretly crowded with mature galaxies right after the Big Bang. There is no need to claim that all prior understanding collapsed. Reality does not need that kind of help. It is enough to know that in some compact early systems, stars were already forming vigorously, gas was already being energized, and oxygen had already appeared. Enough had happened, that is the whole point. Enough had happened for history to start folding inside light. Maybe that is the line that stays. History folding inside light. Because that is what a spectrum from a record-distance galaxy really is when all the terms are stripped down to their living meaning. It is a narrow channel through which an early place tells us that it was not only there, but already becoming more than it had been, already carrying a past of its own, already participating in the long transformation of the cosmos from raw beginning into a universe capable of complexity. And complexity is no small word here. We are not speaking yet of life, oceans, forests, music, cities, or memory in the human sense. But we are speaking of the astrophysical complexity without which none of those later things are possible. We are speaking of stars as engines, galaxies as compact sites of assembly, radiation as environmental force, oxygen as the memory of earlier burning. We are speaking of the first known footholds in a climb that would eventually lead, by many long indirect steps, to beings who could ask where the footholds began. That is why the ending of this story does not belong in triumph alone. It belongs in humility, and in a kind of steady gratitude. Humility because we are still reading from far away, still partial, still refining, still limited by what can be seen and what can only be inferred. Gratitude because partial access to something this deep is already extraordinary. We do not need total knowledge for the result to be life-changing. We only need enough contact for perception to become richer than it was. And we have that now. We have enough to know that the first long darkness did not hold uninterrupted for as long as our softened imaginations once suggested. Enough to know that some early galaxies were already compact furnaces of star formation. Enough to know that chemistry had already begun to remember stars in at least one of these very remote places. enough to know that cosmic dawn was not a metaphor waiting for poetry, but a measurable era of local engines and widening consequence. That's a lot for one species to know, so perhaps the final image should be as simple as possible. A person standing outside at night. Nothing dramatic, no swelling music, just the ordinary act of looking up. Above them is the same sky human beings have always lived under, and yet not the same sky at all. Because now we know that hidden among those depths are messages from unfinished mornings, from compact galaxies already making stars when the universe was barely out of its beginning, from places whose light crossed almost all of time to say, quietly and unmistakably, that reality started building earlier than we knew. The sky does not announce that to the eye, but it is there. And once you know it is there, once you understand that some of the faintest reachable light is carrying the marks of the first known chapters of stellar labour, the night never fully returns to being background again. It becomes what it truly is, a late view into early fire, and a reminder that the universe learned to become more than its first simplicity astonishingly fast. Not everywhere, not all at once, but early enough that, even now, the evidence is still arriving.